So yeah, hi everyone, my name is Upkar. I'm a developer advocate for IBM, and let's talk some serverless. So just quick show of hands, how many people actually use serverless on production today? Okay, some of you. Who's played with it a little bit, maybe on the side? More people? Okay, cool. So what I did was I thought today I'll do like basics of serverless. So for people who have not heard of this term, it's a good session to be in. And then I'll give you a lot of examples and links to go through in more detail, okay? So good news, bad news, I guess. Bad news, there is no serverless. Good news, it's just somebody else's container. And I actually got this definition from the Cloud Native Computing Foundation. They have a white paper on serverless. And then I tried to highlight some points here. So as you probably figured out by now, the whole idea behind serverless is you just give it your code, give it your function, your Lambda, your action, whatever you want to call it, and it runs it for you, it scales it for you, so you're not in charge of provisioning new servers, allocating it memory or CPUs, all of that stuff is abstracted away from you as a developer, so you focus on code. And then the few sort of top common use cases that actually we saw today, people talked about APIs, people talked about microservices, and also event-driven programming, where you're gluing your different APIs and solutions and functions together. Those, in my opinion, are also top 3 use cases or common use cases for serverless, right? So the first one there, most of the serverless platforms come with some sort of API gateway, so you can expose your actions to the external world. And that gives you a couple of things. So one of the things is HTTP level scaling, right? So if I have an example later, but now each of your function could be a get, post, create, delete, update, and you can scale as per demand for each of those actions. The second one is the backend services example. So I actually saw an example on IBM code patterns, which I'll show you in a little bit. But the idea was when you take a picture of a check that somebody gives you, your service gets triggered or your action gets triggered, and it does OCR, picks out the account number, the amount, and then calls some banking legacy probably system to do the transaction, right? So that's use case number 2. I also like that a lot of these serverless platforms give you an option to use different languages. So I mentor at a couple of hackathons, locally and outside, and the first thing I see is when people form teams, it's picking up a framework and picking up a language. And I feel like I always suggest serverless as something that each one of the people in the team can use a different language to code their functions, and then use something like events to make it all work together. So speaking of, for me, the most interesting bit is the event-driven programming. So that's where your actions are reacting to something external happening. And I have some examples of that. But overall, when you think serverless, like microservices, right, it's leans well to small, focused tasks. Also, if you're not entirely sure about how the demand will fluctuate in the future, also a good fit for serverless because you're scaling from 0 to what you need. By definition, most of the serverless platforms are stateless, so that's a plus and a minus. If your application does need that state or session, then you have to manage that by yourself. And here's an example, right? So I'm not a gamer, but I have a feeling that every time a new dance comes out in Fortnite or a new character comes out, people are super excited. So this is showing, actually the red is kind of not showing, but the idea behind this is the demand's going to go up for a certain amount of days or time and then go down eventually. And you don't want to pay for the tail, right? You just want to pay for what is being used. This is another example. So if you have a multi-day conference, for example, first day everybody's excited about the schedule. They get out, they attend sessions, and towards the evening the demand goes down. And then also over the week, as people start to leave, your demand of your actual app usage goes down as well. So again, maybe a good fit for serverless where you're only paying for what you need. In terms of serverless landscape, I get asked this a lot. There are quite a few companies involved right now. So if you look at the bottom, it's the installable version of platforms. So these are generally open source that you can install on your own. And then there's the hosted versions, which are managed by other companies, right? So for us, we have, at the bottom, it's hard to see, but there's Apache OpenWhisk, which is what we use. And then we have a hosted version of that on IBM Cloud. And then, of course, like everything else, people are building abstractions on top of serverless platforms, toolings to do with security, and also CI/CD and things like that. So now companies are coming in and building that layer on top. I picked up a couple of clients. The pictures actually look horrible, but the first one is a image search, hosting and search company. And the case study goes into how they were able to use serverless to reduce their cost. The second one is to do with IoT. So it's a garbage pickup company, and they're monitoring their trucks and analyzing how much load was picked up on certain routes and optimizing those routes as well. Again, to look at the numbers and the actual solutions, I have the link. It's at the bottom. You can go take a look on, as to how they use serverless. This one is also interesting. It's ESPN fantasy football, and they use a couple of serverless functions written in Python to analyze all of the data they're collecting from web crawlers, videos, audio, and then they're using, in this case, they're using RDBMS to store that data, and then they run these functions nightly to produce results that show up on the page the next day. So all of those examples basically boils down to cost-effective computing, right? So you pay for what you use. Automatic scaling, so from 0 to whatever you need for your solution. And the last one is easy integration, and we had another talk before that showed how to glue these things together, and the whole event-driven paradigm gives you a way to do that. All right, kind of went through that. So here, I just want to give you this URL as well. This says IBM Code Patterns. These are GitHub repos of end-to-end solutions, completely open source. You can go take a look. I've picked out a couple from the serverless category. So if you look at the one, maybe the top left, chatbots are a very, very common use case for serverless, right? So the serverless function gets triggered, the container gets invoked only when a message comes in, only when needed. The other one was the image processing one with the cloud object store. So every time somebody puts a picture there, maybe you run some analytics, maybe you just do some processing on the image and store it back. But if you go to this site, they have, like I said, they have GitHub repos. You can fork them and actually run it on your own. So Apache OpenWhisk is one of the open source serverless platforms. It was originally from IBM Research and then donated to Apache. And then we had Adobe, Kong, Red Hat come and join us in this effort. But essentially, you have your actions, you have your triggers, and actions at the bottom is stuff that you run. That's your code, that's your logic. You can pick multiple languages to run that, or there's one of the options is Docker. So if as long as you can containerize your function, you can push it up to OpenWhisk or IBM Cloud. It's called IBM Cloud Functions. And then again, with the triggers, there are multiple kinds of triggers. So for example, if something comes into Slack, you may want to reply, or you may want to analyze what came in. IoT use case, like I said, give an example earlier, database changes with the picture again. And all you have to do is connect your triggers and your actions, and then the scaling happens sort of for you. Here's an example of creating a simple API. I did a webinar with Joyce, who's not here today from Postman. And in this webinar, I created this CRUD sort of API on a cat resource. And then we were easily able to integrate that with Postman and run some automated tests on the API. So I have a link to that webinar later if you want to take a look. But essentially, this is what that looks like. So if you look at it from my right, there is, the user comes in and hits the API gateway. Each of the 4 operations in the API gateway is mapped to a function. And then in that function, I'm using just the CloudEnd or CouchDB, which is the NoSQL database, to actually do the work. And then there's a special condition if a certain color cats come in. So a cat resource has a name and a color, then it fires a trigger that sends an email to somebody saying, hey, if you want to buy this special cat, it's in the database now. So it was fairly easy to hook up. And then for microservices, I have this other example. So we have Again, a completely open source site for deep learning models. So there's a open source team at IBM that their job is to create these TensorFlow models that you can use. And they put it up on GitHub. And so all of them are Dockerized, so they're containerized. And somebody wrote a function, an OpenWhisk function, that essentially takes one of these containers in. The Docker file is in the middle, and that's just, it's just taking one of those Docker file, or taking one of the containers from the models, adding in this special openwhisk.py file, which has two methods. It's got init and run, and the run method is the one that tells it how to consume that deep learning model. So this is another example of an existing resource, which is a already trained deep learning model that you can now, we were able to, I guess, use that in a serverless manner. And there's tons of other events that you can look for, right? So I talked about GitHub. The periodic one is another useful one. I feel like a lot of ad hoc stuff that you do in terms of server maintenance or log files or analyzing stuff, you can put it on it's like doing a cron job, but on serverless. Here's another one. This application is called Dark Vision. And again, this is open source. You can go take a look and run it on your own. But essentially, the idea is you upload a video to CouchDB, and then that triggers a function that analyzes the video and puts out some frame by frame, and then puts out some keywords as to what it thinks is in the video. So fairly easy to create. I created this with this is the simple API version, or processing of form version. So there's a registration page on Glitch, and then you just put in your email and your phone number, hit register. It'll put that in a database and send you an SMS and an email, right? So fairly easy to do. This could be like a one JS file in an Express.js app. But just to illustrate how to do this in serverless, it looks a lot more complicated than a simple file. But essentially what's going on here is the user comes in, the T's in this diagram are triggers, and A's are actions, and R is what connects the trigger to the action. So user comes in, something goes into cloud, the username and email go into CouchDB, and then it triggers a sequence of action that uses SendGrid and Twilio to actually send the email and the SMS. So again, just to show how every little piece here is decoupled to each other, and each one can be scaled or removed independently of the other. All right, so those are all good things about serverless, but there are also some things you need to think about before you move into a serverless platform. Right, so the first one I already mentioned, functions are stateless, so if you do need to persist state or sessions between your function calls, that's your responsibility, and you need to take care of that. The second one is are you able to test and develop locally? As developers, we have our IDEs, and we like to develop locally. And maybe you're on the BART, you need to do it locally. So does your provider provide ability to be able to manage that? We saw some examples earlier today from Amazon. And then the other one is how do you version your functions? So you're still writing code, you're still writing. You still want to follow the practices that you've been following all along. This is I feel like serverless gives you a way to think differently about your different components and how to break down the problem into different functions and actions. But you still have to do CI/CD. How easily can you monitor your individual functions? Logging, that's a big one, right? Because if you think about the whole event-driven paradigm, then functions are being fired asynchronously, and there's the whole concept of time goes away, right? So the linear time goes away. So how do you then follow the trail from one function to another in this paradigm? And then the other one is, of course, avoid long-running loops. So what happens is, at least in OpenWhisk, they have a time limit on how long you can run a function, and it happens to be 10 minutes, which is pretty long time, right? So you have to think about, if you are using serverless and creating these very short functions that are very focused, then how do you have to, when you're designing it, you have to think about not doing the mini monolithics. Latency is a big problem. So that's when the first time you run a function, it goes and spins off a Docker image and puts your code in it, runs it, gives you the result back, and then some other, at least in OpenWhisk, some other class or some other process goes and collects all the logs. But the first run could take a couple of seconds. And is that acceptable to you or not? And how do you avoid that? Right? So that's another thing to think about. And the last one is track dependencies on a function level, so on your sort of binary output level and not your source level. Is there a way to do that or not? So this is the webinar that Joyce and I did with OpenWhisk and Postman, and I've got the link down there. I'm hoping everybody gets these slides later, so you have the link to go take a look. And I tend to speak very fast, so I'm done. But I'll be back there if you have any questions. Thank you.